All right, good morning, everybody. So today is April 6th, 2023, and we are going to continue our discussion on ER modeling today. Let's see here. But first, as usual, so I can get the right slide here. Oh, okay, hold on. Looks like PowerPoint may be having some issues. Yep. Hold on, let me kill PowerPoint and turn it back on. Let's try this again. Make sure all my notations are done in there. Yep, okay. That should be good enough. Sorry for the technical difficulties. Let's close that out. Okay, let's try this again. So the file's corrupt, we'll see. Okay. All right, back to what I was saying. This quote of the day is from Sir Arthur Conan Doyle. You may know him as the author of the Sherlock Holmes series of novels. And he brings to us this quote that says, "I never guess." That sounds like Sherlock Holmes, right? It's a shocking habit destructive to the logical fallacy. So faculty, not fallacy, something different. So don't guess, right? Make sure we analyze the system for how it should be developed to be able to help us to understand how we should design our system using, as we are talking today, using our modeling concepts, our entity relationship modeling concepts. Okay. All right. So where we left off was we analyzed, we didn't guess about how the staff and branch relations, or the staff and branch entities in this case, should be related. We didn't guess about that. We didn't just throw up some random numbers here. We actually tried to figure out, okay, how should these things be related? So one of our relationships is this manages relationship. Remember, we also had the has relationship where the branch has staff. We had both of those. Those are two relationship types, two relationships that the staff and branch entity have with each other. We don't guess about it. We say, okay, how should staff and branch be related as far as the manages is concerned? Well, a staff person doesn't have to be a manager at a branch, so we put a nice 0 here. The staff person, if they are a manager at a branch, they can only be a manager for one, so we put a 1 here. On the other hand, the staff must have one and only one manager, right? So 1 ... 1, indicating that minimum of 1, maximum of 1. Okay. as you can probably figure out, certain rules would apply here, like this number on the right cannot be less than the number on the left of two dots like that. That wouldn't make any sense, right? We can have numbers other than 0 or 1. We talked about that, those examples where you had like 3, 6, 9, like 3, 6, or 9 involved, that kind of thing. You can have other numbers involved, but generally the left number will usually be a 0 or a 1. The right number will usually be a 1 or a star. Now there are other options. Like I said, we can give that a branch, if we had like the works at relationship, the branch has staff. You might say that a branch can have a maximum of 10 staff people or something like that. You can have that that restriction, that constraint. But I would say usually what you will see is a 1 or a 0 on this side, a 1 or a star on this other side. Okay. All right. So ER models are great, right? We love them. They're wonderful. They solve our problems, but there are some problems that come up with them. And specifically, as we start designing things, we may introduce what's called a trap. Two main types of traps that we will talk about in this course are called fan traps and CHASM traps. Okay. So a fan trap, where that's a bunch of words, but basically it's where a pathway between one entity to another is ambiguous. Like we don't know how to get from one entity on the left to an entity on the right. Okay. A CHASM trap also it can help, but the problem can be we don't know how a particular entity instance, a row, if you will, connects to a row in another table, but it's for a different reason. So both of them are about we don't know. We think there should be a relationship between two entities, but we don't really know how to get there. So let's just look at an example. Okay. So here we have an example. It makes sense, right? A division. So let's change up some of the wording on this. Let's, instead of division, let's call this a faculty. Okay, so like the Mühendislik faculty, you know, or the, what else do we have? Do we have other faculties? Are there any other really important faculties beside the Mühendislik faculty at the university? Probably not. Well, we don't. There's the only important one. Okay. All right. A faculty operates or has, let's not call it branch. Let's call this departments. And since I hate writing with the mouse, we'll just leave it like that, like an abbreviation. So here we have departments like the computer engineering department, the electrical engineering department, and things like that. Okay. Staff, you guys know what that is. We can just leave it as that. But you know, this would be like your teaching staff and could be your non-teaching staff as well, like our secretaries and other support staff, right? So here we'll say the faculty has staff. Yeah, I work for the engineering faculty. Yeah, that makes sense. I can only belong to one. I belong to one and only one. Yeah, that makes sense. Faculty has one or more staff. Yeah, okay, I'm okay with that. On the other side, the faculty operates departments. So if you have a department, computer engineering, that exists, it must belong to one and only one faculty. Yeah, sure. It operates one, the faculty operates one or many departments. Okay, yeah. Because you got computer engineering, electrical engineering, environmental engineering, InShot, civil engineering, right? All those. Okay. So it seems like it works well, right? But when we look at that semantic net that we talked about before, right? So now, okay, now we're sticking with this whole, let's see. Faculty and department, right? All right. So you have a staff person, let's say this is me, all right, that I work for the engineering faculty, right? And the engineering faculty has the computer engineering faculty, computer engineering department, rather. Let's call this E. This will be another faculty. What can you be? This could be, I guess, the foreign languages faculty. So then we would have what, the English J, the English department. All right. So we have a staff person who works for the engineering faculty, but we can't tell from this which department they're in, can we? Right? Because that relationship isn't defined. We don't have a relationship between staff and department. Okay. Now, we could, right? What we could try to do is we could try to say, okay, well, what we'll do is we'll add another relationship. Okay, so we have, right, faculty, we have department, we have staff, all right? We have those two relationships there. We could say, let's add this third relationship between staff and department. That could be true, but I think we misunderstand the way these three are related if we think that this relationship here is necessary, right? Because the way to know which faculty I'm in can be done through the department that I belong to, right? In order to figure out that I am part of the engineering faculty, we could do that through I work for the computer engineering department, which is part of the engineering faculty. Or someone else might work for the English department that's part of the foreign languages faculty. Right? So this third relationship really doesn't need to be a third relationship. It needs to be a relationship that replaces this one here. Okay, so if you see how they will show this solution, right? Where our division, or what we called faculty, branch that we call department, all right? So faculty operates departments, departments have staff, right? And the way to determine which faculty someone is in is by going through the department entity. So if I can say this staff person belongs to the computer engineering department, therefore they belong to the engineering faculty. Okay. So if we look at the semantic net examples here, with that trap removed, now we can see how that works, right? So here we go through the branch. I changed that to department, we know. We go through the branch to get to the division. We go through the department to get to the faculty, okay? So make sure that when you see that, you see something that looks like this, make sure that you have not misunderstood the way two things might be related. So if you have a situation like this where you have a one-to-many relationship on one side with participation being required, a one-to-many relationship on this side with participation being required, it can represent this fan trap. The reason it's called a fan. If you look at my screen, my video, right, it looks like a fan, right? A fan kind of fans out, right? And so the center point being the faculty or the division fans out to the left, or your right, and fans out to the left, your left, right? But if the thing on the left and the thing on the right have relationships with each other, then this could be a fan trap. Does not mean that every time we see a one-to-many relationship on one side and a one-to-many relationship on the other side of the same entity, that must be a fan trap. That's not at all the case. It's not always a fan trap. It's just that if we see that, we need to ask ourselves, before we say this is a good design, we need to ask ourselves, is there some type of relationship between this and this? Okay, because if there's a relationship between those two, then we could be at risk for a fan trap. Okay, and I say could be because we're going to see in just a moment in the CHASM trap how we may introduce what looks like a fan trap to fix it, but it's not actually a fan trap for particular reasons. Okay, everyone clear on the fan trap before we move on? Okay. All right, so now here, let's just leave it with the branch staff instead of trying to figure out what staff oversees. I mean, I could put students over here, but this has to be a 0 here. In order for this to be a CHASM trap, this has to be a 0, and you'll see why. Okay. So branch has staff. This is the same relationship we saw previously, right? Staff must belong to a branch. A branch has one or more staff. Makes sense. Okay. Now staff oversees properties. Now a staff is not required to oversee any properties, okay, but they can. Okay. Now when I said earlier that this 0 is important, this 0 is not important for the CHASM trap. Okay, it could be a 1, it could be a 0, either or. Okay, so this is just part of the way this relationship is designed, that a staff is not required to oversee any properties, but if they do, they can oversee as many properties as they want. Okay. This 0, however, is important for the CHASM trap. Okay, because this 0 is telling us that a property for rent does not have to be overseen by a staff person. If it is, it's overseen by only one. There's not 2 staff people that oversee the same property, right? But if it's overseen by a staff person, it's only 1. It doesn't have to be overseen by any staff person. It might just be operated by a branch. So a branch may deal with properties and not have a staff overseeing it. Right? Maybe it's a new property and we haven't assigned it to a staff person yet, or something like that. Okay. All right. Or maybe the staff person who was overseeing it quit, left, they found a new job. All right. And so now they're not overseeing that property anymore, and we haven't assigned it to someone else yet. Okay. So if we look at that semantic net, all right. So now we have, okay, how do we know which staff person this property for rent is overseeing? Well, there's a relationship there. How do we know which branch is overseeing? Which branch is maintaining this property? Well, we can go through the staff person. So if this staff person is overseeing it, then this branch is in charge of this property. Same thing with this bottom one. So we see how to get from the property to the branches through the staff person. right? And same thing with this one down here. Okay, but what about this property? Okay, so a branch office is maintaining all the different properties, but we don't know which office is maintaining this property because no staff is overseeing it. That's where that 0 on the staff side, the participation of the property for rent entity in that relationship, that 0 is what makes this a CHASM trap. Because there's no requirement for a staff person to be overseeing it, we cannot know which branch is maintaining it. Okay, if there's no staff there, right? So how do we fix this? What we can do is we can add a third relationship. Which branch offers? That's the word they want to use. Okay, so a branch offers a property for rent. Now, if there's no staff overseeing the property, we can know which branch is offering it through this new relationship. Okay. A branch offers one or more properties. A branch, a property must be offered by a branch and only one branch. Okay. Look at our new semantic net. Now we have this new relationship to the property for rent. Okay. New relationship with the property for rent. Okay. All right, so one thing I want to say about this before we move on is one of the downsides to the way that we have to solve the CHASM trap problem, one of the downsides is that now we have to make sure that data stays consistent. So say, for example, PG36 is overseen by staff SG37 who works at branch B003. Okay. And PG36 is offered by branch B003. Okay, that doesn't seem to be a problem, but what happens if somehow someone changes this PG36 and says, okay, it's now overseen by SA9. Okay, so this is no longer there. PG36 is now overseen by SA9. So now, if we were to say, okay, what branch offers this property? Well, if we go through the staff table, we get B007. But if we go through the offers relationship, we get B003. Okay, now that could be a problem. That means that data is not being held consistent. So one of the things that we will need to do is we will need to make sure that our data is consistent. And because what we will learn during the logical design phase, is that the way these relationships will be designed is to use foreign key columns. And say for the property for rent, we will have a foreign key column there that points to the staff table to tell us which staff person is overseeing it. We will also have a foreign key column to the branch table to tell us which branch is overseeing it, is offering it. And if the staff person doesn't work at the same branch as the property for rent foreign key column branch, that could present a problem. Right? That could present a problem that we will need to make sure whether through our program, our procedural PL SQL triggers, or there's different kinds of ways that we can do that. But that will be something extra we will have to do to make sure that data remains logically consistent. Okay. All right. Any questions about these traps before we move on to the next section where we start getting into a little bit more advanced ER modeling concepts? Or any questions from yesterday's lecture? We could also talk, if you guys have any questions from yesterday's stuff. I don't want to move on because now we're going to get into slightly more advanced stuff that ER modeling can do. Okay. All right, so we look at, that's basically the outline. So, right, some of the limitations of the basic concepts. Because if you noticed, if you guys look back to UML, okay, if you look back to UML, can somebody tell me something that you used pretty frequently in UML and Java that we didn't use so far in our discussions of ER modeling? Anyone? Because the relationships we've talked about so far are very similar to what we would call aggregation or composition. They're associations, basically. And we talked about that in UML. Our entities are basically our classes. You guys remember there was something else that we used, some other type of relationship, some other type of, oh, I gave a hint. Does anyone remember UML? Are you like, right, inheritance. Yes, Oscar, thank you. So inheritance, remember, and how did we draw inheritance with that nice, fun triangle with the line, right, where you had one class type up here, one class type down here, right? And this would say this was the parent class, this was the child, the super, and the subclass, right? This was something that we included as part of our UML modeling that we haven't shown yet here in ER modeling. So guess where we're going, all right? So that's where we're going, okay? So this whole concept of a superclass and a subclass, right? Now a superclass to subclass relationship is what we'll call one-to-one. Now you may say, wait a second, one-to-one. But I remember we did stuff like this where you had a parent, right, that had, you know, multiple children. So wouldn't that be 3-to-1, Hojam? I'm confused. I don't understand why are you saying 1-to-1? It's because each one of these is a distinct relationship. Okay, so we're going to see that even though we draw them kind of all as one, the way that they get implemented is they are 3 distinct relationships. One is a relationship between this child and this parent. One is between this child and this parent. One is between this child and this parent. Now that's not to say that these 3 relationships won't impact each other. Now, in UML or Java, those 3 relationships did not really impact each other in any way. It wasn't like you could say, oh, this one is a child of the same parent as this one, and we could know that. Like that wasn't like that had any impact on each other. Okay, not like in a family where children have great, oh my goodness, great impact on each other. Like this. Just try to get 3 kids out the door for school on time. Oh, it's terrible. Okay, so, all right. But each one of these is a one-to-one relationship with its child. Okay, so the parent has, let's say the parent has a very unique relationship with each of its children. All right. So, okay, so we'll talk about this whole not all members of a superclass need to be a member of a subclass. So this would be that if you have someone that is, if you have a table, an entity that is part of a superclass, a parent class, it doesn't have to be one of the children. This would be the same as saying this superclass, this parent class, is not abstract. Remember, if we had an abstract superclass, then we would be forcing that our objects would have to be one of a child type, right? An abstract superclass says this has to be a specific type, right? We can't have an object of the superclass type if it's abstract. Okay. So in the same way, if we make this class not abstract, we can have an object of that type. All right, so that's basically what this last bullet point is saying. All right, so let's take a look. A couple of things. So attribute inheritance, right? So an entity in a subclass will represent a real-world object. So they'll have some attributes. So it'll get attributes from the parent, but it will also have some of its own attributes as well. This is all basically the same UML. All right, so and then we have specialization and generalization are two words that we will use for this type of relationship. There's some main differences between those two, but for the most part, for the purposes of this course, we'll just let that be something you can look into on your own. All right, I won't focus on that. All right, so let's take a look at some an example. So let's imagine we have a staff table that contains all the information for the staff in our branches and our well, we don't have a branch number here, do we? So they should have a branch number, maybe in the large staff table they would, but this is basically it's going to have all the details of our staff people. So notice some columns are specific to managers. So if a person is a manager, they have a start date for when they became a manager. They have a bonus. What is their bonus? Maybe like a yearly bonus or something like that. Okay. We have someone that is a salesperson. Okay. So a salesperson will have a sales area. Where is their area they're going to be in, and what is their car allowance? So they have a car allowance they have to spend or can spend. Right? Maybe something like typing speed for secretary staff or what might be called administrative assistants. Okay. Now notice that we have a couple of people here, Ann Beach, for example, or Mary Howe, for example, who are assistants. They don't have any special columns. So they aren't one of these managers, sales, or secretarial staff. Okay, so you can be a manager, you can be a salesperson, you can be a secretary, or you can be some other position that we don't have special columns for. So the way that we might represent this in a diagram form, in an ER diagram, right? Forget about this for a second, for just a moment, for the branch part, right? Is we have a staff person who can be a manager, they can be a sales personnel, they can be a secretary. Okay. Now this is something we haven't seen before in UML. This optional and designation here. Okay, optional means that a staff person can be one of these, right? But they don't have to be. Okay. They can be a manager, or they could just be a staff. They can be a sales personnel, or they can just be a staff. They can be a secretary, or they can just be a staff. right? Okay. Now, and so optional means, as its name implies, optional. It is not required to be a child class. Okay. The other one here, the other designation here, and, is saying it can be more than one of these child classes. So a staff person could be a manager and a sales personnel. They could be a manager and a secretary. They could be a sales personnel and a secretary. They could just be a manager. They could just be a sales personnel. They could just be a secretary. They could be none of those. They could be just a staff person. Okay. So they could just be a staff. They could be a manager. Not in M, right? They could be a sales personnel. They could be a secretary. Right. They could be any combination of these, right? So there's lots of different possibilities, right? They could be a manager, sales personnel. They could be a manager of secretaries. They could be a sales personnel and a secretary. They could be a manager, a sales personnel, and a secretary, right? Okay. Yeah, so they could be any combination, including just a staff person. So this optional would be similar to saying this class is not abstract. Right? So that is a really bad typing. This is why I don't like writing with the mouse. All right. So this is not abstract. This optional is saying that it can be just a staff. All right. Let's talk one more about this side over here. Remember that we used to have this relationship between staff and branch, right? With a 0 on this side and a 1 on this side. Right? That was the manages relationship. We used to have that. And we don't have that anymore because now that we have this child class manager, we can say only managers are allowed to be a branch manager. And we can identify who the branch manager is through the manages relationship with the manager class or the manager entity. Right? And so now instead of 0.1, the way that 0 gets translated is by saying not all staff have to be managers. You can have someone that's just a staff person or a sales personnel or a secretary that's not a manager. So they won't have a relationship back to the branch to say that they are a manager because they're not a manager. Okay. And now we can say that a branch has to have one and only one manager person, and a manager has to have one and only one branch. Okay. So this has been able to better define this relationship, right? Because the way that this relationship was defined before, you had to have a staff person. It didn't have to be a person with the manager title, right? It could be anybody. We could make the janitor be the manager if we wanted to. The only rule was that once a branch had a staff person that was a manager, that was participated in this manages relationship, no one else could. Once they had one, right, they couldn't have any more. That was the only rule that was applied there. And that a staff, it's actually the other way around, isn't it? It should be this and this, that a staff person doesn't have to be a manager or branch. Whoops. No one caught that. No one wrote me and said, "Hey, you messed that up." I need you guys to keep me correct on these things. I make mistakes. All right. Ask my wife. I make mistakes all the time. Now, my wife may not tell you that. My children will definitely tell you I make mistakes all the time. All right. So this clears this up a little bit, right? Because right now, the way this old relationship worked, if a staff person, if a staff person was called a branch manager, even if their position wasn't manager, that was okay. It didn't violate this relationship. A branch, once they had a staff person that was a manager, once they had a staff person that was a manager, they couldn't have anybody else. Again, there was no rules about what their position title was, according to this relationship. Now, by having it done this way, with this relationship over here, right? Okay, so I'm going to say that this becomes this relationship here, right? By doing it this way, it becomes easier to enforce the business rules, like the branch manager must have the position of manager. We can enforce that rule now. A manager must have a branch. So if someone has that position, they must have a branch that they are the manager of. That becomes easier to enforce this rule. Okay. All right. Let's go ahead and pause there. Yeah, we'll come back and talk about another generalization, right? Another specialization generalization relationship, also involving staff, but different on these words and how they work. But we'll do that after the break. So are there any questions before we break, or any comments before we break? All right, we'll pause there, come back at 11:30, and we will continue our discussion from there.